Hi students, it's Mrs. Blackman here. I know that many of you started our first week of number pattern sets, and I wanted to do a quick video just going over the answers with you. So I'm starting off on our first set, number patterns number 1, which you can see here at the top of my paper, and I'm going to go ahead and tackle those first two problems. It says that you can use cubes and the tables to solve the problems. I'll be just using paper and pencil today, but you're welcome to use what you have at home. If you don't have cubes, but you have other things that you can count with, paper clips, dried beans, pieces from a game, any of those things will work. So let's go ahead and get started. Let's look at number 1. It says, on Monday, 2 crabs are in the Seahorse sub on the first trip down into the sea. 4 crabs are on the second trip. 6 crabs are on the third trip. And 8 crabs are on the fourth trip. If the pattern continues, how many crabs will be on the 5th trip? So what we can see here is that our table has come in handy to organize the information from the problem. They did the first 3 trips for us, and you're simply adding in the 8 on the 4th trip. As you can see, there is a very, very clear pattern here where we are going up by 2 each time. And there's also a pattern between the number of the trip and the number of crabs. So you can sort of think of this as the trip times 2. So if trip 1 times 2 is 2 crabs, trip 2 times 2 is 4 crabs, and so on. So on our very, very last 5th trip, we would have 10 crabs. All right, let's go ahead and look at number 2. On Tuesday, 2 clams are in the sub on the first trip down. 3 clams are on the second trip, 4 clams are on the third trip, and 5 clams are on the fourth trip. If the pattern continues, how many clams will be on the 5th trip? Here they've left a little bit more for us to do. We don't have any of the clams written in on the right-hand side of the table, so we're going to start with that. So it says on the first trip down, there were 2 clams in the sub. Then it says 3 clams on the second trip, 4 clams on the third trip, and 5 clams on the fourth trip. As you can see, there is a pattern here again. This is going up by 1 each time. So we can think of this going forward as n plus 1. N plus 1. Sort of like when we did the first one, we did 2 times n, or you can write it 2n. Okay. All right, n plus 1. So we're taking the trip, and then we are adding 1 to get the number of clams. Okay. All right, so our first set was pretty straightforward, pretty easy. Let's go ahead and tackle our second set of problems. This is number patterns 2. On Wednesday, 3 toads are in the Seahorse sub on the first trip down, and 6 toads are on the second trip. 9 toads are on the third trip, and 12 toads are on the fourth trip. If the pattern continues, how many toads will be on the 5th trip? Here you can see they have a little bit more for us to do than our first set. We have to number our trips going down all the way to our 5th trip, and then we're going to fill in our information on the right-hand side. So it went 3, then 6, then 9, and then 12. Again, we can see that this is going up by 3 each time. You can also think of it as our n, our trip number, times 3. So 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, and so on. In order to get my 5th trip, I'm going to multiply that by 3, and I will get the number 15. 15 toads. Okay. 15 toads is my answer. All right, moving on to our second one on set 2. We're going to go ahead. It says on Thursday, 5 snails are in the sub on the first trip down. 10 snails are on the second trip. 15 snails are on the third trip. And 20 snails are on the fourth trip. Clearly we can see a pattern emerging here once again. Our trip is our n. Each n is being multiplied by 5. So n times 5 is going to help us to figure out what our 5th trip will be. So 5 times 5 is 25. So there's our answer. Okay. All right, so we'll go ahead and write 25 snails as our answer. Okay. What I really like about these sets is that they increase in demand each time, and they also sort of start you off with the table already made, and then you each time have to make more of the table on your own. But by that time, you sort of have the hang of things. All right, let's go ahead and we're going to check out number patterns number 3. All right, we had 2 problems for this one, and it said, on Friday, 15 turtles are in the Seahorse sub on their first trip down. On the second trip, there are 13 turtles. On the third trip, there are 11. And on the fourth trip, there are 9. I'm noticing right away that unlike my other problems, it seems that the number of turtles are decreasing each time. They're not going up, they're going down. So on my 5th trip, I would expect to have even less than I did on my previous trip. So if this is going down each time, it looks like by 2, I'm going to think of that as my minus 2. Minus 2. Okay, so 9 minus 2 would be 7. Another way that you can think about this is how it relates this way. Okay, we can say that 1 times 15 would give us 15, but you can see here that doesn't work this time. 2 times 15 isn't going to give me 13. So I know that I'm not multiplying necessarily each time like I did before. So this time I need to think about it a little bit more. Actually, what we're really doing is we are starting with the number 17. Watch what happens. This is 17 minus 2 times our trip number. Okay, so if this is our trip number, that would be 1 times 2, which is 2, and 17 times 2 would give us 15. Now let's try it again here. What's 2 times 2? 2 times 2 is 4. 17 minus 4 is 13. Here we go again. This one's 2 times 3. 2 times 3 would be 6. 17 minus 6 is 11. Okay, it seems to apply each time. My rule is applying and working out for me every time. Let's try it with 4. 4 times 2 is 8. 4 times 2 is 8. 17 minus 8 is 9. So in order for us to check our 5th trip, 5 times 2. 5 times 2 is 10. And then 17 minus 10 is 7. All right, let's go ahead and look at the second problem. It says on Saturday, 20 snakes are in the sub on the first trip down. 16 snakes are on the second trip, 12 snakes are on the third trip, and 8 snakes are on the fourth trip. If the pattern continues, how many snakes will be on the 5th trip? Let's go ahead and fill in our table. 20 on the first trip, 16 on our second trip, 12 on our third trip, and 8 on our 4th trip. Again, I'm looking at a decrease in numbers as we go down. I would expect that my 5th trip would have even less than 8. This appears to be going down by 4 each and every time. So 8 minus 4 is 4. So that's pretty easy to find our answer here. 4 is our answer, just like 7 was our answer up at the top. However, we're also going that extra step to think about our algebraic equation that we could use. It would be our rule every single time. That would work for us every single time. If you've had a minute to think about it, you have come up with 24 minus 4n. 24 minus 4n. Let's check that out and see if it works. 4 times our trip number is 1, so 4 times 1 is 4. Let's check and see. Is 24 minus 4 20? Yes, it is. Let's try the next one. Trip 2. 4 times 2 is 8. 24 minus 8 is indeed 16. 4 times 3 is 12. 24 minus 12 is 12. 4 times 4 is 16. 16 minus 24 minus 16 is 8. And then let's try it with our last final trip here, the 5th trip. 4 times 5 is 20. and 24 minus 20 is indeed 4. So our algebraic equation applies every time, and that's going to be our rule for every single one of our problems on this trip. All right, thank you all very much, everyone. I'm going to go ahead and we will stop the video for number patterns 4, 5, and 6. You can tune in to my next video. Take care, everyone.